Okay, it's 12 o'clock. Start our Zoom meeting. We have one other participant at the moment. I don't know. Oh, it's Miss Anderson. Okay, very good. Did you have anything you wanted to see today? Any problems you want worked?
Honestly, I was just kind of here to see what other people. I personally didn't really have anything, but I was gonna see if other people did. So if no one else is here, I mean, I personally didn't have anything specific any questions specifically. So
Okay,
I don't
it,
know.
sure thing. This is back to 2.3 and 2.4.
Yeah.
I guess, go through section by section. I tried to show some, I don't know if you saw any of the Monday Zoom meetings. We could go through. I worked problem 7 Monday. It was reading these values off of a graph, say. Would you need help with any of that? They give you really one other one, which is number 9.
No, I understood those.
Okay. Well, then we jump.
Honestly, everything that I've gone through so far, I've understood okay. I wanted to know what other people kind of had questions on because I mean those spike questions too, but I personally didn't really have any
Okay.
questions. So.
Sure thing, no problem. You can find domains and ranges of this sec, because we did this section.
Yeah,
Okay.
I know how to find the domains and ranges of those.
All righty. So we jumped over here and see we skipped we skipped doing stuff graphically, so we skipped all this. I'm
Mhm.
skipping increasing and decreasing. We skipped all that. And yeah, even down here, increasing and decreasing, we skipped all that. And this local max and min,
Yeah.
I'm skipping all that. And basically, yeah, that was it. I kept it was a 2.3 here, pretty short. I skipped the applications. So
Okay.
that was pretty much it for 2.3.
Okay. Well, I mean, I understood all of that personally, so
Okay.
I don't.
All
Yeah.
right. Sure thing. Let's see. So then we jumped to 2.4, which was about the net change and average rate of change. So I started on 2.4 with problem 7 and 9, which gives you the points on the graph. Net change was the difference of y's, so basically vertically, y2 minus y1, and that's the top of the average rate of change. Average rate of change is the full slope of that dashed line.
Yeah. I've always kind of struggled with the like average rate of change, but I mean,
Okay.
if you wanted to go over one of those, you can do that.
Now, on the graphs, you can just read the points.
Yeah. Like I struggle with like when you don't have a graph.
Okay, so that started at problem 11, and we went through 23,
Yeah.
and then pretty much finished with that. And yeah, they give you the two X's, but
Yeah.
you've got to plug those in and get the corresponding Y's to do the net
Yeah.
change, and then finally to do the average rate of change. Is there anyone in particular you'd like to see?
Hold on, let me go to one. Oh, my computer's doing something though. I don't know what that did. Okay, so for the X's, are we just supposed to like plug them in?
Uh-huh. You, you usually take like the lowest, it always goes from the lowest X to the highest.
If it doesn't give you the X's, or okay, I'm overcomplicating it now. Are we gonna learn that later?
No, it'll give you
Like
the
if it
X's.
doesn't,
That's standard.
it'll always give you the X's?
Yeah, even if it doesn't call
Okay,
it.
I think I'm okay then, honestly.
Oh, okay. Like in 15, they use T's,
Yeah.
but they're the input variable. I
Yeah.
just generically call it the X's because
So
that's what
you just plug it in and get your answer, so
right, you plug it in, you get your Y's, and then
yeah.
the net change, you subtract the y's only. And
Mm-hmm.
average rate of change, you subtract the y's and divide it by subtract the x's. That's your slope.
Yeah. Okay. I mean, I understand. I understand that. So,
Okay. If you don't want to
I
hang
mean,
around,
I think I'm personally okay. So,
yeah, if you don't want to hang around, that's fine. I think I'm only 5 minutes in, and I'd like this to last at least 15 or 20 minutes, so my bosses at the school think I'm earning my money. So I may work 2 or 3 more, like 19. I may work 19 because you see it's got that T is 3 and T is 3 plus H. I may work something like that. And
19 the oh yeah, where you
see, it's got letters.
okay.
19, 21, and 23 have letters. So that makes them a little more, instead of just pure numbers, makes it a little tougher.
Yeah, but it should still just be the algebra, right? I haven't done those ones yet, but
That's right.
it should. So basically, if you do that, if it was like for 19, 3 plus H, would you keep the F on one side, or like can you just show me how you would like set it up, and then I think I'd be okay, but.
Sure, absolutely. This is page 224, 2.4, 19. All right, they're giving you that f of t is 5t squared. They're going from t equals 3 to t equals 3 plus h. Okay. Remember, this entire thing is your y. And so these are x's. I'm going to call this usually the first one they give, the lowest one, I'll call this the x1 and this the x2. So on net change, we just generically call y2 minus y1. I get the y2 by plugging x1 into this. Well, I can do it right here if I want. I'm going to
Can you
get.
do the X? Okay, so you're doing X1.
I'm sorry. I see. I actually.
Can you
Yeah.
do the second one, the like
The,
3 plus
yeah.
H?
So yeah, I did it backwards. I crossed it up. My fault. So actually,
There.
yeah, the y2 I'll get by plugging x2 into this. So actually, that will be 5 times 3 plus h squared.
And then do you have anything on the left side?
No, this is just it. I mean, this, they're just calling it net change. When it says find the net change, that's what I'm setting up here. So on the left, this is not an equation to be solved. This is just net change. All right.
Okay.
And the y1 comes from plugging x1 into this. So that'll be minus 5 times 3 squared.
Okay.
Okay, so that's the setup. The book probably foils all this, figures this out, and boils it down. Do you want to see that to match the book answer?
As long as I can like set up the equation, I mean I can do all that, but so I'm probably gonna head out, but you can keep going. I mean.
Sure thing, no problem. Yeah, you head out, no problem at all. I'm gonna work B.
Thank you.
Sure thing. You have a good rest of the day.
You too.
All right, so then the average rate of change takes y2 minus y1 over x2 minus x1. So that will take 5 times 3 plus h squared times 3 squared and divided by 3 plus h minus 3. That's your x2 minus x1. Okay, I'm going to go ahead and I'm not going to simplify that. I'm going to go ahead and simplify this. And you see the bottom goes to h. The top, hold your 5, 3 plus h, 3 plus h, minus 45. If you'll notice, 3 squared is 9 times 5 is 45. So that gives you 5 times 9 plus 3h plus 3h plus h squared minus 45. All divide by h. That FOIL went too quick for you. You're going 3 times 3, 3 times h, that's 9 plus 3h. H times 3, another 3h, and h times h is h squared. All right. I'm going to go ahead and kind of speed this up a little bit. Well, maybe I won't. 5, 9 plus 6h minus 45, all divide by h, and I ran out of room. Again, this is still average rate of change. You're not doing everything to both sides. You're just working this out to its simplest form. So, holding this, 45 plus 30h, 5h squared minus 45 divided by h. You can see the 45s cancel. 30h plus 5h squared, all divide by h. These are unlike terms, so I can't combine them, but I can pull out the common factor of h, actually a 5h, because 5 goes into 30. I'll vacuum out the common factor. That'll leave me a 6. So 5h times 6 is my 30h, and an h, all divided by h. 5h times 6 is 30h. 5h times h is my 5h squared. My h's now cancel, and I'm left with 5 times 6 plus h. That should be the answer in the back of the book. I'll look it up and see. Page 224, it's 2, 4, number 19. Okay. 2419A boiled down to that. I didn't do that, I just left it alone. But 19B, 5h plus 30. You can see 19B, this is in the book. See, I have add 5h plus 30. I have 30 plus 5h, so they've switched it around. 5h plus 30. Why don't we try 21? That brings in some fractions. (2.4), page 224. Problem 21. G of x, 1 over x. X is 1. X is a. This is simple enough. If you want to call this x1 and x2, see your y1 is going to be 1 over 1, which is 1, and your y2 is going to be 1 over a. You get your y values by plugging your x's into this. Your net change, y2 minus y1 takes 1 over a and minus 1. The book probably gives a common denominator and everything, but that's just switching the form of it. I'll just leave it like that. And b, your average rate of change, 2 minus y1 over x2 minus x1 would take 1 over a minus 1 over a minus 1. I'll simplify this to get the answer in the book. You need a common denominator on top. All right. So that means your average rate of change, 1 over a minus 1 over I'll need to stick in A for a common denominator, which equals A. My common denominator on top will equal A, and then I'll have to multiply again by that on top. That means I get a 1 minus A all over A minus 1. You stick that over 1 if you want. And then you divide fractions by taking the top times the flip of the bottom. Top, flip of the bottom. 1 minus A over A times 1 over A minus 1. I hope you realize or remember rules of canceling. No, these don't directly cancel, but you can cancel them with a -1 because they are switched. Winding up with -1 over A. Double check that in the back. 2.4, it was 21. Okay, yeah, they did get a common denominator form in 21 on the top. The net change, they have 1 minus A over A. Yes, and then B, they have -1 over A, which is exactly what I got right here. Book up here has a 1 minus A over A. See, if you got a common denominator, you have an A over A. And there's your 1 minus A all over A. But you don't have to do that. You could have left it 1 over A minus 1. It's fine. All right. I would try one with pure numbers. Maybe I'll work one like 13. Hadn't done 13 before. Just, I hope this is getting natural to you. I can give you the shorthand version of it. 2.4, 224, 13. H of t, negative t add 3/2. T is -4. T equals 1. See, I'm going to call this my x1 and this my x2. So my y1 is going to be -4 add 3/2. And my y2 is going to be a -1 add 3/2. You put -4 in there, so you get 2 negatives, which means y1 is going to be 4 add 3/2. You could get a decimal if you wanted, but basically I need a 2 there for common denominator times 2. That's 8/2 add 3/2, which is 11/2. And over here, y2 being a -2 over 2, because remember I put a 2 there and 2 on top, add 3/2, I'm going to get 1/2. -1 add 1.5, you're going to wind up with 1/2. 4 being 8/2, add 3/2, you're going to get 11/2. So part A, my net change, y2 minus y1, that'll be 1/2 minus 11/2, -10/2, which is -5. B, my average rate of change, again, I'll write down the full formula, y2 minus y1 over x2 minus x1. I just plug in the -5 because I've already figured my y2 minus y1. x2 minus x1 was 1 minus a -4. I went with -5 over 5, which equals -1. You can almost see it. It's identical to slope. If you know your mx plus b, you can instantly see your slope is -1. It's the coefficient on your, well, I always want to say x, this one they're using t, but it's the coefficient on your letter here. They're using t instead of x, but it's straight line, first power, mx plus b. Your m is -1, and that's what we found. All right, just for completeness, why don't we go back to 2.3 and let's work a domain problem, say like 19. Page 215, this is from 2.3. F of x is then square root of x minus 1. And they want you to, part A, get a graph. Part B, domain and range. I'm going to do the domain just from the formula. For the domain, square root of x minus 1, with the square root problem, you've got to make that greater than or equal to 0. So x is greater than or equal to 1. Put your number line 1, closed circle, because it's got an or equal to, shade that way, infinity. I guess I should come a little lower with the range, but domain, 1 comma infinity, bracket, parentheses. We're going to see this off the graph, and I could have read it off the graph if I'd have wanted to, but for the range, need a graph. Because there's no way to know for the range, you're going y min, y max, and there's no way to know what those are. That's what the calculator shows you on the graph. The pixels that get lit are your output values. Without the graphing calculator or a graph, you can't really see them. And doggone, I've frozen. I come back. Okay, maybe it'll come back. Okay, here we are. So, clear, square root, x minus 1, close. Doesn't tell me what window. I'm going to use my -10, 10. Graph. And you can tell, it seems to, at the first tick mark, it doesn't really have a closed circle. Come up with a curve like that. And so that's what this is telling you. Pixels start getting lit as it's sweeping. The calculator is sweeping across from -10 to 10, but it's not lighting up anything back here. You don't like -3. -3 minus 1 is -4. Square root, and you just can't do it. It doesn't light up anything until you get to 1. And then when it lights up 1, plugging in 1, you get a 0, which is why it's starting on the x-axis. And then with positive numbers here, these are the y values you get out. So the x's start at 1, go to infinity, and you can include 1. The range vertically, the x-axis is y0, so it's 0, 1, 2. So for the range, you're starting at 0, and this will go all the way up to infinity, so parentheses there. And yes, you are on the x-axis. 0 is legal output. And I guess I should have redrawn the graph back up here. One tick mark, going sideways. You have your graph. And there's its domain, set of x values. And there's its range, set of y values. All right. We'll, if there's any other questions? No questions or comments, we'll end the meeting. And there'll be another Zoom meeting tonight at 9 p.m. We'll see you then. He's gone in his room, closed the door. I'll get him for you. Sterling,